So we talked about hypothesis testing, and now I'm going to tell you about one of the um, most important uses of hypothesis testing, which is clinical trials. So what are clinical trials? When a drug company develops a new drug, the final and the most expensive part in the development is the clinical trial. The drug company needs to prove to the FDA, to the Food and Drug Administration in the United States, that their drug, let's call it D, reduces blood pressure, let's say. So how do we do that? We select a representative set of patients, randomly select have to be cases and have to be controlled. The cases will receive the drug, and the control will not receive the drug. The random partition of the patients into case and control is what helps us show that what we're talking about here is causation rather than just correlation, right? Because we're controlling the causal reason for something, and if there is now a correlation, we can deduce that there is a causal effect. However, there's some problems. One of the problems is that studies have shown that patients that receive a sugar pill, placebo, do significantly better than patients that receive nothing. So if they think that it is a real effective drug, then they do better than if they don't get a drug. So the solution is to give all patients an identical pill, and half of the patients get the pill with the drug and half get just a sugar pill, but they look exactly the same. But then studies have shown that patients that receive treatment from a doctor who knows whether their pill is real um, or placebo do better than patients whose doctor knows that this pill is a placebo. So the solution is to do what is called double-blind trials. So neither the doctor nor the patient knows whether the pill is real. So there's no way for them to somehow influence the result. Okay, so we have the setup of the experiment, and now we need to set it up in terms of hypothesis testing. So the a priori opinion of the FDA is that the drug has no effect. That is what is the null hypothesis. So the null hypothesis is that the mean blood pressure is the same for the case and for the control. The goal of the drug company is to reject that hypothesis with a predefined confidence level alpha, so typically 5% or 1%. The drug company has to declare its plans for conducting the trial and evaluating the dependence before starting the trial. Otherwise, they have this degree of freedom that later they can say, oh, actually we decided to use this kind of analysis for the data, and just present the analysis that was favorable to them. The kind of hypothesis test that we're using here is the two-sample t-test, which we talked about briefly before. And it's a test to compare the means of two samples. So these two samples are given, the case and the control. And the assumption is that the sizes of the samples are big enough that we can assume that the distribution of the mean of the average is normal, central limit theorem. The null hypothesis is that the case and the control have the same distribution, same mean and same standard deviation. The alternative hypothesis is that the mean, the blood pressure in this case, is smaller than the mean of the control, but the standard deviation are still equal. So this is the difference between the null and the alternative. And we set a confidence level that is alpha is 0.005 for 5%. Finally, we get to the day of the trial, or the weeks of the trial. The trial is done according to the pre-authorized protocol. Then the results from the trial are put into two-sample equals standard deviation t-test. And the p-value that is calculated is the probability that the results were generated by the null hypothesis. Remember, p is a random variable and alpha is not. Now, if p is smaller or equal to alpha, then the null hypothesis is rejected and the drug is FDA approved. Okay, so now the drug is FDA approved and can be sold as such. On the other hand, if p is larger than alpha, then the trial failed, the drug is not approved, and the investors are very unhappy. But that's the way it is. Okay, maybe they needed to use, maybe the drug wasn't good, or maybe just they didn't use a big enough sample. It's not possible to know at that point. So there are other types of studies that are becoming popular, and it's important to know what the difference is. So these are called observational studies rather than controlled studies. And let's say that we want to compare again the effectiveness of approved blood pressure drugs. So you have a lot of different types of drugs here. And you can get from CVS, Walgreens, and so on, the purchase orders for blood pressure medicines. You get from the healthcare providers the electronic medical record that shows how they're doing in terms of blood pressure. And then you compare the effect of the different drugs. The difference is like this. In the clinical trial, the sources of bias are controlled, right? So we basically select a random set of patients, and then we select from them a control and case, and treated and are treated. And then we can compare and know exactly what is the correlation. However, it is hard to get more than 100 patients because in a controlled trial because each patient is so expensive. This causes large variance, right? So we don't have bias in this case, but we have a very large variance because our n is relatively small. In the observational studies, we cannot show causation, and there is a danger of large bias. But on the other hand, we can have hundreds of thousands of patients, which means that our variance is very small. And the bias can be reduced by various correction methods. You can group patients by age, gender, and so on to control for these other variables. So, of course, there are other issues with doing studies like that. One is patients' privacy. So patients that go to CVS didn't necessarily agree for their information to be used. Big pharma and big hospitals have their own interests. And that's it. So the clinical trial is the tried and true. This is basically the gold standard that is currently still used by the FDA. But there's more and more attempts to try to bring in observational studies.